All right, pre-algebra kids, I am going to go through lesson 21 with you now. Countdown to the end. Basically, what lesson 19 and 20 told us, we're going to combine in lesson 21. So you're going to be solving equations using both the additive property and the multiplication property. So the first example we have here on the board is 2x plus 2 equals 18. I always start with the additive property. I don't know why, I just do. It's just easier for me. So I see I'm adding 2. I'm going to subtract 2 from both sides. Those cancel. I get 2x is equal to 16. Then I'm going to divide by 2 on both sides. So those cancel. And I get x is equal to 16 divided by 2, which is 8. To check my answer, I then take 8 and plug it back in. So I get 2 times 8 plus 2 equal to 18. Well, I know 2 times 8 is 16, and I do know that 16 plus 2 is equal to 18. Therefore, 18 is equal to 18. It checks out. There's your first example. I'm basically going to just be showing you how this is done over and over again. Please feel free to re-watch if you need to. Here's another one. With this one, though, we have an x on this side and an x on this side. We need to get the x's together. So I'm actually going to subtract the 2x from this side and on this side so that way it can transfer over. Why am I subtracting 2x? Well, this is add or positive 2x. So if I subtract 2x from this side and subtract 2x from this side, because these are like terms, I can then say 2 is equal to 2x. Divide by 2 on both sides, I get x is equal to 1. Okay? Let's check our answer. You take 1 and you plug it back into your original answer. So 2 times 1 plus 2 is equal to 4 times 1. Let's see if that's true. Oh yeah, you have to plug it in over here too because you have an x. So 1 is plugged in both sides. Well, 2 plus 2 is definitely equal to 4. We learned that when we were in kindergarten, don't we? So, therefore, it checks out. Let's go through some more examples. 2x plus 3 is equal to 15. Again, I always start with the addition. I don't know why, it just makes sense. Minus 3 from both sides. Those cancel, you're left with 2x is equal to 12. Divide by 2, so those cancel. Divide by 2 on this side because you did it to the other side. X is then equal to 6. Double check, plug it in. 2 times 6 plus 3. Is that equal to 15? Well, let's figure it out. 2 times 6 is 12. If we add 3 to that, it sure enough is 15. All right, pre-algebra kids, so I tried really hard to cram all the lessons into one day, and it didn't happen. My phone died, and that's why I'm in a new outfit. And so today I'm going to finish the lesson that we were so rudely interrupted with, which was lesson 21, I think? Yes, lesson 21. So we were doing algebraic equations that have multiple steps. So they use the addition property, and they use the multiplicative property. We finished this one here, 15 equals 15, check that off. Now we're going to do 5x minus 4 equals 21. Again, start with your addition. So remember, this is just like adding a negative, but I always just say do the opposite. So if you're subtracting, you add 4 to both sides, then you are left, those cancel, so you're left with 5x equals 25. You divide by 5 on this side, so that cancels. Divide by 5 on this side, you get x is equal to 5. But again, we always check our answer, so we take that 5 and we plug it in for x. 5 times 5 minus 4 equals 21. 5 times 5 is 25, minus 4 equal to 21. Oops, I put 20. 21. Yes, 25 minus 4 is 21. Therefore, 21 equals 21, and it works out. X is equal to 5. So, this is another example of how you can use both the additive property and the multiplicative property. Let's do some more examples as we move along here. All right, so this one is just backwards in the way that it's written. It has the equal to at the beginning. 17 is equal to negative 5x plus 7. Still start with the addition. So I'm adding 7, I'm going to subtract 7 from both sides. If I subtract 7 here, I get 10 equals negative 5x. Those cancel. Then I'm going to divide by a negative 5, so those cancel. If I divide by a negative 5, I get negative 2 equals x. Well, let's check that out. Plugging it in. 17 equals negative 5 times negative 2 plus 7. Negative 5 times negative 2, since they're both negatives, equal a positive 10. And I'm adding 7. Oh, and sure enough, 17 is equal to 17. Checks out. All right, so just because this is backwards or written differently, still works the same way. 35 equal to negative 6x minus 1. Again, I start with the addition. I'm going to add 1 on both sides so that these will cancel. I get 36 is equal to negative 6x. Divide by negative 6 so that those cancel. Divide by negative 6. Since there's only one negative over here, I get a negative answer of 6. 36 divided by 6 is 6. And that is equal to x. That's my answer, but before I do that, I should check. So I'm going to take it and plug it in. 35 is equal to negative 6 times negative 6 minus 1. Negatives times together equal a positive, and it's 36. 36 minus 1, sure enough, does equal 35. Therefore, it works. Your answer is negative 6. I hope this is all making sense to you. I've given you several examples now. I think I have a couple more, and then we are done. I chose these ones because notice that we have 2 x's. This one you have a fraction. So here we need to combine those x's. I think it would be easier to bring the 4 over to the 8. So we're going to subtract 4x over here to cancel those out. And we're going to subtract 4x over here because whatever we do to one side, we need to do to the other side. Those cancel. And here we get 4x remaining because 8 minus 4 is 4. And that is going to be set equal to 12. So now we use the multiplicative property, which would be saying that we would times by 1/4. But instead of timesing by 1/4, I'm just going to divide by 4. Same thing, right? Divide by 4 on both sides. You get 3 over here, and you get x is equal to that because those two cancel out, all right? Let's double check that. We have 2 places to put 3 into. We have it here, and we have it here. So 4 times 3 plus 12 is equal to 8 times 3. Double check this. This is 12 plus 12, and this is 24. Is 12 plus 12 24? Absolutely. It checks out. Your answer is x equals 3. All right, now for this last example. Before we get to this fraction, we're going to do the opposite of adding 3. So subtract 3, subtract 3. You get 3 here, those cancel. This is equal to 2/3 x. Now, doing the additive here is going to actually benefit us because it's already a fraction. And when we multiply by the inverse, it cancels out. So if we multiply 2/3 by 3/2, the 3's cancel and the 2's cancel. So since we multiply by 3/2 on this side, whatever we do to one side, we got to do to the other side. So we're going to also multiply by 3/2 over here. Reminding you that 3 is equal to 3 over 1. When we multiply 2 fractions, we multiply across. So we get 3 times 3, which is 9 over 2. This is all equal to x. Okay, that's our answer. That's what we're saying x is equal to. But let's check that out. So I'm going to take 9/2 and I'm going to plug it in to 2/3, or next to 2/3. So 2/3 times 9/2 plus 3, does that equal 6 is our question. All right. First we multiply across. 18 over 6 plus 3. 18 divided by 6 is 3. Yes, because 3 plus 3 is definitely equal to 6. Therefore, 9/2 is a correct answer. It checks out. So that one was probably the trickiest one, but if you remember how we can add or can multiply by a fraction when we have multiplication, that helps you out. And you need to multiply by the reciprocal of that fraction, which is just the flip of that. If there's any questions, I'll see you in the Zoom. Go ahead and do your homework.